Hello. Hey guys, can you hear me? Hello. 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 Can you hear me? Hello. All right, cool. Hey guys, we're gonna get started. If you wanna take a seat. Guys, we're gonna get started. Please take a seat so we can get this event started today. There's a lot of seats up here, if you don't mind. Awesome. So, thanks again for coming tonight. Appreciate everyone showing up for this event. I haven't done a meetup in over a year, so it's been a while. I promise to have a few more meetups as we progress through the year. But just quickly want to announce DataCon LA. How many of you are familiar with it? It used to be called Big Data Day LA until last year. Raise your hands. Come on. You know you've been there. Exactly. So we're running a special promo if you sign up by tomorrow. It's 20% off. It's $30, but still, if that helps any bit, feel free to do that. As in last year, we're going to have a pretty great event. We expect about 2,000 attendees, so it'll be great as previous years. It's going to be at USC again, middle of August. Other than that, take a flyer. The promo code is on that. And that I just want to quickly thank Headspace, our host. So thank you, Headspace. Appreciate it. Victor, you want to come and say a few words?
All right. Can you guys hear me? Yeah, I'm Victor. I work on the talent team here at Headspace. Happy for you guys coming out. Happy to support the community. Really just happy to kind of host the event for everybody. So hope you guys have gotten some good pizza, some good beer, and are excited for the speakers today. If anyone's ever curious about working at Headspace, feel free to contact me, Lindsay in the back as well. But other than that, hope you guys have a good night tonight.
So with that, we're going to kick off our presentation. I'm going to invite David from Neo4j. David's a Canadian, so don't hold that against him. And then David will kick it off with speaker for tonight.
Hello there. My name is David Vesey from Canada there, eh? How you doing? So my name is David Vesey. I'm at Neo4j. I've worked on fishing boats. I've done all kinds of crazy GIS and analytics, but coming to the U.S., I've just worked in the world of data. So I'm just going to give you maybe a quick overview of who Neo4j is, and then we're going to have Justin Fine, our field engineer, kind of tell the story all around the Panama Papers and the Russian trolls that were found out by NBC. So Neo4j started as an open source project in 2001. There was our founder, ML from his team was just getting frustrated with relational databases and just doing too many SQL joins, and the data going slow for their offering they had to ad agencies there. And so they said, well, they looked around, they couldn't find anything like a network database. They were like, well, let's just build it ourselves. So they did that, and lo and behold, in 2009, they decided to go commercial. In 2012, they brought it over to the U.S., so our headquarters is now up in San Mateo. All our engineering team is still in Sweden and in London. And so we've just been having a lot of great success when people are finding it really difficult to analyze data that's quite large and highly connected. So we want to thank you Headspace and Big Data LA for letting us host tonight. And we'll let Justin Fine introduce himself and jump right in.
Just before we get Justin, and just one quick thing. If any of you stay after the event, Headspace has agreed to take us on a tour. So, that's a good promotion for you to guys to come and take a look at Headspace. It'll be interesting because we have 4 buildings out here. I can show you all the cool things we do out here.
Another sort of quick announcement. So if you do stay to the end, we have some some Neo4j swag, and as well as some Amazon gift cards. And we have a little bit of a trek. We have some training in San Diego next week, so we have 2 free giveaways to Neo4j training next week. So we'll just start with that.
Cool. Thanks, David. So I'm also teaching that San Diego course. So if you don't get the answers you want today, come on down and talk to me. So I thought David was going to go over the salesy slides, but we'll do the salesy slides. Graph tour. Big graph conference in San Francisco. We actually host a lot of those because our base is close to it. So take a look at that. I think we're going to put this up on the website, or usually we put the slide deck on it. You can just follow the link. Also, really exciting, some of our fellow Neo4jers created a graph algorithms book, and I hit my head against solving these first in Python, then in SAS, then in MapReduce, and now I just click a button and do like 3 variable inputs, and I get it for free in Neo4j. It's awesome and also infuriating that I didn't have this like 12 years ago. So I recommend checking this out. It's coming out later this year. I think there's one chapter's online ebook available. So if you want to check that out, that's cool. Amy co-authored it. She's super, super smart. We're trying to get her to come over and do like a specific Neo4j for data science training, which will be unbelievably interesting. And I think I'm on the hook for presenting that too. So just a little reward for being so loud about how it would be awesome to have over here. So cool. Here's what it's kind of covered. Really tiny print, but as you can see, a lot of stuff. There's a lot of awesomeness in this, and anybody who's done this, even one of these, like in centrality algorithms, you're gonna be like, oh man, that took me like a week to write. Well, you get it for free now out of the box, so you're welcome. Cool. So me, with sunglasses on, because I don't have a more professional photo, but I thought I had a really good haircut that day, so I needed to send it to my mom. It's either this one or my LinkedIn, which is like shoulder-length hair, which is crazy. There's my address, my email address. If you have any questions or think I didn't cover something I should have, please feel free to email me. My LinkedIn, you can go check out that cool hipster hair. And then my GitHub, which is purely what I use to store the documents for my trainings that I give. So. And I still have the sunglasses. They're awesome. My favorite. So as any narcissistic data person starts off a presentation, it has to be about me. It's about me. So my story, my journey in Neo4j, in Arrows tool, by the way, which we'll talk about that in training. But you can see that I've kind of lived many, many, many lives because I chased these very interesting problems and started off with academia and math, and then I realized it was more interesting if I went to London to solve some problems over there for fraudulent actors. That's when I started writing a fraudulent actor analysis algorithm that took 8 days to run on SAS. That's days to run in a terabyte of data. It's insane, right? So I came back, went to work for the little intel agency called the NSA, and did a similar thing with MapReduce. Different type of actors, but MapReduce. And that still took me 8 to 9 hours to run after making many, many mistakes because I'm not a Java guy. Also, there was no external internet. All right, I don't know if you guys have ever not used Stack Overflow, but oh, good Lord, it was frustrating. I had to like take my error message, write it down, then go to a computer and like look it up and hope I didn't mess up somewhere. Infuriating. So yeah, after that, and I got super sick of that, I went to a consultancy, we'll call it Accenture, It took me across to AT&T and JP Morgan, and I found out everybody else was kind of trying to catch up with what we were doing in the UK and also with the government, which is not a surprise, but also kind of weird. So I helped them do that in MapReduce and Python and that sort of fun stuff. But I don't know if you guys are seeing a trend here, but all these big data problems and all these issues that I had over the years kind of led us back to this. They were all graph problems. They could easily be solved with my knowledge in graph theory, and then the gap was me putting that into code, which is a fairly large gap. Although I'm doing better nowadays, but it was larger back then. So anyway, so what we're going to talk about is why that's important over today, and then also when you guys all sign up for the San Diego training, also that whole day too. So what we're all here for, Russian Twitter trolls. Internet's an awesome thing, but also is terrible because you can do some really, really nasty things with it. Specifically, you can mess with people. And troll is a term. I'm not sure who has heard the word troll. If you ever play online video games, you're called a troll every 3 seconds. It's basically just a nasty person doing nasty things in an environment where there's really no punishment. In this specific case was Twitter had some people that were really, really, really smart in the way that they were targeting influential people in networks in the United States that could potentially sway elections or events or things like that. What do I mean by that? Well, I mean specifically if I am a flag-waving American that drinks Miller Lite, I like certain types of things, right? Or if I am a beret-wearing, espresso-drinking, turtleneck person, I also like a specific group of things. And this is obviously generalities, but again, if you have enough sample size, then you can find these patterns or these clusters of people that exist. And it's surprising to see the people that vote are usually in one demographic. So this last election was the same thing as you can possibly imagine. It's very interesting. Well, Twitter found these people out. They thought they were really, really smart about it. They deleted all their accounts and all their tweets. And then they came up with this awesome idea, hey, should we try to prevent that from happening again? Yeah, you should probably do that. Oh, but we deleted everything. How are we going to do this? And after scratching their head for several, I'm sure, internal meetings where everybody was yelling and whiteboarding, they realized that they needed some help. So I talked to Neo4j. And Neo4j said, hey, that's a graph problem, so all we need is the data. Can you give us the data? And they're like, actually, we can't do that. So you have to find the data yourself. There's a really cool tool called the Wayback Machine, or Wayback API, which allows you to go back into certain chunks of time and get information from the internet. So if you think you're safe because you deleted something, you are wrong. Somebody's going to dig that up, like your 50th birthday or something. Like, hey, you remember when you said this really terrible thing? And you're like, that wasn't me. I was a troll back then. Don't judge me. So anyway, so we went back to the Wayback API, pulled all the information out that we could. We had a subset of usernames that we were given by Twitter. And we thought, well, there's probably more, so why don't we get all the information, all the tweets? And my tweet lingo is bad because I don't twit, or whatever it is, the thingy. So if I say something wrong, don't judge me. But there are hashtags involved, and there are, usually there's lingo involved, and usernames, and people who follow usernames, and things like that. So we can build a pretty easy graph from that data. So we did. So we took an initial clustering of people and kind of blew that out. And I'm pointing the wrong way again on the screen. So we scraped that data. It's all JSON. The hardest part of all of this was getting the JSON out. After that, it was pretty easy. And when I mean hardest, this is the actual code. This is the actual code. That was the hardest part of all of this, was figuring out how to model the data and how to put it in correctly so we could use it later. It's actually not all the code. There's 2 lines missing from the top. which is your load JSON. So that's just so deceptive. It's not 20 lines, it's 22. So yeah, we pulled all that JSON in. We iterated. Don't let me pretend that we did perfectly on the first time. You will probably mess up if you do this on your own the first time. But it was a couple passes, and we got it in. I did it again. So it yielded 350,000 tweets, 41,000 users, and only 450 trolls. But that's actually way more than they thought. So win, right? I think it's right. But we weren't done there. No. We could not just leave it at that. We wanted to know what kind of people did this, and if we're going to miss them next time, what they look like, right? So we started doing things that were really neat, and there's a really good talk on the Neo4j site. But basically, we hooked up the Stanford's natural language processing engine to our little Neo4j, and we actually could profile people's tweets based on hashtags and based on their sentiment around it, whether they were being sarcastic, or whether they were being nefarious, or whether they were actually truly being sincere. Thank you, Stanford, for the open source. I actually spent like an hour on this earlier today at their website. It's really cool. I don't know if you guys have seen it, but like it's a ridiculous amount of examples. And their NLP is very, very high tech. Bunch of smart people there. So what did it look like? Oh my gosh, I've used NLP before. I've done n-gram analysis. It took me forever to write. That's the code. How crazy is it? That's actually the code. It just calls, it makes one APOC call, which we'll talk about a little later, basically one stored procedure, and it pulled those natural language processing algorithm components from the API at Stanford and allowed us to look at the text and the tweet and the ID of the tweet, and then see all the annotated text associated with it. That's all that says. This is very human readable, and we'll talk about this in the training. This is supposed to be human readable, and it is. You can walk through somebody else's code and actually read it. I don't know if anybody's read a Perl regex lately, but I'd see you give me $1 million, I wouldn't be able to read somebody else's Perl regex. So, kind of cool, right? Well, let's give us an example, huh? The naysayers in the group, I don't believe you. What are you talking about? Well, this is our first use case. Leroy loves the USA. Nothing fishy about that, right? That's totally a normal name to have on Twitter. He's got a dog. Oh, he's a good old guy. He probably drinks Miller High Life, like plays catch with his kid or whatever. He's saying some really nasty stuff about Obama, and then does the little hashtag thanks Obama. Well, some people actually thanked Obama, and some people were saying it sarcastically. Well, this guy was saying it sarcastically, so we built a little graph and sentiment analysis on that. Very, very blurry. It's not supposed to be this blurry, but it is. On our website, it's much clearer. So why is that interesting? Well, one of the cool things about Neo4j is that you can use a temporal aspect to look at when things happen with large groups of data. And what we found was Leroy really liked tweeting a day before any sort of election or debate or any significant political event, and he would do it at about 4 a.m. Alabama time. I think he was in Alabama or something like that. We were like, maybe he's up at 4 a.m., but that's also like 3 p.m. in Russia, which would make way more sense. So yeah, we did this little correlation thing and found out it truly wasn't just somebody who couldn't sleep well. It was somebody who was in a different country. And they were doing all these really, really nasty things right before big things happened in our government. And we also do that with every other tweet as well. So we were kind of doing our research to make sure that our conclusion that we made was getting closer to something that we could act on, something that was actionable intelligence. I mean, as much as I love giving random facts to people, actionable intelligence is much more interesting. So we found it out. You're cheeky. Russian troll, Leroy loves USA, and it was fishy from the start. But we also have things like Cleveland Online and 10GOP, which are less fishy sounding. That sounds legit. I mean, if somebody has a Cleveland Online handle, I assume that means they are from Cleveland and they're some sort of political person or something like that. So we found a bunch of these people out and did some more analysis. But let's take a step back, because I like taking steps back. I don't know how many of you guys have dealt with Neo4j, so maybe we got a little ahead of ourselves with all of this talk of Twitter and ingesting JSON and Wayback APIs and all that sort of fun stuff. So let's take a step back and look at it. Most people, when you say graph, they think this. Oh, can we put it into Excel and see a nice little table or a scatter plot or a pie chart? That is a graph. I don't mind Excel. Excel has its functions, but this is actually what we mean when we mean graph. Graph theory. So it's all derived from graph theory and Euler, one of my favorite mathematicians. Has a lot of really good stories, and it's the most beautiful equation voted by all mathematicians. So take time, take a look at it. Cool Wikipedia page. So that's what we mean. We mean nodes, and we mean connections between the nodes, or vertices and relationships. Depends on how many languages you want to talk about it. Also a cool little slide. We put that in there so you can chuckle. Nobody chuckled, so I'm going to keep moving. All right. So what do we mean when we say graphs are everywhere? We mean they're everywhere. And my little spiel in the beginning was just kind of telling you why it was everywhere. It's literally in every problem. Fundamentally, there is a math problem underneath it, usually. In this case, we're talking about graph theory. So real-time recommendations. I don't know if you guys have ever had like a really bad recommendation in Amazon. Do you guys remember like 10 years or 12 years ago, and when you get like, hey, I'm going to buy a pair of weightlifting gloves, and you're like, how about dog food? You're like, what, are you buying something? I don't think, no, I'm on a diet. So that was really frustrating, and it's frustrating for everybody, specifically because you are losing people. If I'm recommending something that they don't want, then I don't trust. I lose some sort of credibility with the company, right? Well, it becomes an issue also when I'm recommending things underneath a certain pay scale. For instance, I have a Louis Vuitton handbag, and I know that because my mom and my sister are very, very big Louis Vuitton fans. And then you're like, hey, how about a Kipling one? And for all the people that give me weird looks, that's lower, apparently. So you don't want to suggest a lower one. If you already have a high one, you want to go to, I used to know the name, Berkey? No, one of the ones that are like $10 or $15 or $20,000, whatever those are. Anyway, so you want to suggest things that are up if that is your business model. Fraud detection. People are hemorrhaging millions of dollars a year, and that's why I've been employed half of my career, is because if we can stop it even by half or even by 10%, then we're going to get some of that money back and contribute back to our savings. Network IT management. I don't know if you've heard of a company called Microsoft. That was the last one I was at. They have a lot of VMs all over the world. They have a lot of microservices on each of those VMs, and if somebody has a VM that has a microservice that goes down and they call me at 2 in the morning yelling, I need to be able to solve that problem and figure out how to get them onto a different VM that has the service. How do I trace that back? Fundamentally, that's a graph problem. You make those connections. This region, this server, this microserver, this person's going to lose service. So even before anything happens now, I can say, hey, we need to do a rolling update to, let's say, Cosmos DB, since this goes down a lot. Who's going to be really mad when that goes down? Okay, great. We'll call those people up and say, hey, turn off your non-production system because we know it's not production, and let us do this update. Anyway, so yeah, there's a lot of these examples, and there's a lot of talks on each of these. I won't go into any more of them because we want to clip along. So why is Neo4j so great, and why do I take every opportunity to kick people? Mostly because I love the product, and I love my team, and I love the engineers. Otherwise, because we're the only graph native database out there. So what that means is the things that you get out of the can, out of the box from Neo4j are the things that make us special and make us hard to build fundamentally, right? So if I have a bunch of Mongo instances and I throw a graph type of layer on top of it, that's not really a graph database. That's just like a bunch of stuff on top of another NoSQL database. So what we're doing here is we're saying we're chasing pointers. I know exactly when I enter something into Neo4j what the ID is. From there, I can find the data and chase pointers until I get all of the information back. Fundamentally, that's our awesome thing. And when I say sub-second, I mean sub-second. So if anybody has done a join in SQL, you understand it can be fast or it can be slow. But if you do 1,000 joins in SQL, it's going to be slow. And that's something that you do not need to do with Neo4j. So that's our bread and butter. We have people that are doing tens of thousands, things like that. So, so yes, that's one big differentiator. And also, yeah, fixed size. We discussed that. So this is kind of awesome. I've been at a lot of companies, and to help the world make sense of data is actually our thing. We do that. We try to help everybody solve problems. If we go into your area and we help you do a data model and we try to make it work, if it doesn't work, we're going to tell you don't use it. We don't want you to fail. We don't use technology incorrectly. We don't sell you snake oil. That's not what we do. Emil and our leadership were fundamentally brainwashed into making this an awesome product and making you guys love it. So it's awesome and love it with me. So yeah, very different than like Microsoft, which they were like, yeah, you got to eat the dog food and tell everybody if everything besides SQL is not good. So getting back to what we were talking about, and does this look familiar to anybody? Is this what we usually deal with, right? Like, can you email this to somebody? Hey, can you fix this for me or put it somewhere where I can get it back out? Yeah, we can do that. Okay, great. And then I start writing Python and things spiral out of control with many caffeinated breaks. That's typical. But we have these tools like Excel to throw into pie charts and bar charts and scatter plots and heat maps and what other thing is. It actually, depending on the boss, they actually love this stuff, right? You throw it into an Excel spreadsheet and you get a little pie chart, and you're like, hey, here you go, boss. And he's like, that's awesome job. Keep it up. Just keep being awesome. And I'm like, all right, I didn't do anything, but I'll take the credit. But we kind of got a little bit more sophisticated over time. And we said, hey, well, why don't we do something with the data? We can throw it into SQL. We can throw a bunch of different types of data into SQL and do some cool stuff, right? Well, yeah, you can. I mean, SQL does a lot of good things very well. They do some things very poorly, i.e. do 1,000 joins recursively. That's not something it does very well. And we're all used to this, right? These diagrams and SQL statements and having 100, 200 lines of SQL code to do something that should be really, really, really easy. And in your mind, you're like, this is easy, right? Like, I know I only have to do 2 levels down and get, maybe people that are underneath a manager in a certain region, and I have 3 databases to go to do that. And then my code somehow starts looking like this on the right, and I'm like, wait a second, this is supposed to be like really easy. Yeah, exactly, and it totally works, and it only takes an hour to run. But there's only like, a gigabyte of data, so it's kind of weird that it takes an hour to run, but whatever, it works, right? So yeah, so we're very used to this stuff. We don't have to worry about it anymore. So I said that very quickly, but I don't really mean it. So we still have a place for relational databases. They exist. But as we're starting to understand the graph database and what it is and how you can think about it from your RDBMS background, this is a really great picture. And I see a lot of people clicking when they see, oh, okay, I get it. I'm doing a person has a friend of a friend. Okay, so I want to find somebody's friend of a friend, no problem. So that's what it is. Or right out of the box, just load it in Neo4j, and I see, oh, Andreas has 3 friends, Tobias, Mika, and Delia. That's that's awesome. They know each other. Well, I can keep adding on that and growing the model and making more and more sophisticated. Really, really cool, all right? So again, these are baby steps. We'll get to more complicated stuff, I swear. I've seen a lot of people. Okay, so fundamentally, this is what it looks like. Property graph model. So we have a person who has a relationship to somebody else. I always use my cat as an example. I would be up on the left there, and my cat would be on the right. I love my cat. She likes me back. So I'm still trying to break that gap. It's only been 8 years. I feel like 8 more, and she'll love me back. But at least she's excited when I feed her. So, but what does that tell us? That tells us that I can do 2 connections in one. I can say, oh, Justin loves Penny, my cat, and Penny likes Justin. And there's no white space, and it's just 2 things connected, right? So that's great. Where that gets interesting is like people that own a lot of homes and rents a lot of them out, things like that. I own this home, I rent this out, I live here. My daughter drives my car. Insurance companies love doing stuff like this, right? Who's driving your car? Who's the primary owner, the secondary owner, things like that. So building those relationships and building those nodes and here relationships. This is where we start seeing the real benefit of having a graph model and a graph database. So what comes with that? Cipher. First time I've said cipher, I think. Not only a character on the matrix, but also a very, very powerful tool. I don't know if anybody has played with Gremlin. Yeah, so I've also played with Gremlin, and that is not fun. It's a very, very difficult language. I equate it with Erlang because I did not like Erlang. So it's very easy to write. So we're going to keep going along. This is what a cipher statement would look like. I'm creating 2 nodes in a relationship. That's it. So, human readable, create person Dan loves person Ann. Dan and Ann. Boom. Easy, right? So these are the definitions. This is how we describe it in in the lingo, and that's what we would describe as the nodes. So Cipher is SQL for graphs. We'll say that. It's standard. It's fantastic. It's good language. It's good base language for anybody to learn. So the Panama Papers. This is a fun one. Okay, so does anybody know about the Panama Papers by any chance? Yeah, right. Okay, crazy. So I didn't before I joined Neo4j because I don't read the news because it depresses me. This would actually make me very, very happy and smile because a lot of really nasty people got found out. They were hiding massive amounts of money. They were doing really nasty things to screw over all sorts of different people that didn't really need that extra thing on their plate. So some of the things that happened here is like money laundering. If I have what that means is like if I have a son who is selling a townhouse for $300,000 and somehow it's sold for $2.7 million. That's fishy, right? Like, I mean, he might live in San Francisco, and it might be totally normal, but most of the time, this is what we start seeing in these. A lot of them are easy because it's like, I can go one hop out, and a hop in this case would be like one relationship out of a person, an actor. I think there are even soccer players. Like, I think Messi was in this, which bums me out. He's like a really good soccer player. I don't know if you guys watch soccer. But, Putin, people like that. We'll see that in a second. So what did we start with here with this problem? So they came to us and said, hey, can you help us? We need some help. We heard you guys are a graph database, and we can't do it with any other tool, so let's start doing it with this. We had 200 journalists all over the world need help. They actually won a Pulitzer Prize for doing this, which is really, really cool. I don't know what a Pulitzer is, but I think it's pretty high up, and it's a prize, so I think there's money with it. So that's kind of cool. What happened with it? Well, we exposed a lot of nasty people, like we said, a lot of politicians, a lot of world leaders. Some people resigned in shame, and other people just were like, whatever, I don't care. Like Putin, he didn't care at all. He's like, fire me. But yeah, so there was a lot of data. Just to give you kind of scale on this, so when I was at Booz Allen, my boss's boss was actually the boss of Edward Snowden. And we can see somewhere up there, there's some Snowden stuff, WikiLeaks, I guess, whatever. That's tiny. And we're talking 1.7 gigabytes as opposed to 2.6 terabytes. That's all different types of data, too. We're talking about dumps and scans and photos and all that sort of fun stuff. There's just a lot of nasty, nasty data in this, which is really hard to look at, and especially if you have all this disparate, seemingly disparate data, pulling it together in an intelligible way is really, really difficult. Especially when we're talking about this many emails we have to go through and figure out what the sentiment is on it. Luckily, we already have that Twitter example, right? So we know we can do sentiment pretty easily. But like, you know, and one email can have what? I don't know if you guys do email chains, but I do. You know, I can have like 400 emails on one email chain, you know, and it lasts 3 years long or whatever. It's really hard to pull that in and make sense of it. In this case, specifically, what we wanted to do is figure out the context of everything. So all these people, we knew all the components and we knew basically what we were looking for, but we didn't know what we were going to find. So we're kind of stumbling around there. A basic data model we were looking at was kind of like, okay, well, I know kind of what people do. I own this holding company. This holding company buys something owned by somebody else and that sort of stuff. We didn't really know how big it was going to get, right? Well, after a little bit of playing with it, we realized this little measly list of little data and entities was not going to cut it. So we started adding more. We add the relationships in. Now we're seeing where money was flowing towards a directional graph. I don't know if you guys heard of that, but it allows us to understand kind of that way that money is flowing by adding a little arrow on the end. It's pretty straightforward. Max min flow, if you guys have ever done that, that's similar to that. But the roles attached with them, and how many open accounts do I have, how many people manage my accounts, things like that. So this is our basic model, right? That's not bad, right? You just throw it in there. You got peak clients, registering a company, shareholders, officers, things like that. Well, that turned into something a little different after a few iterations. And by a few, I mean a lot. This is actually the real data model that we used for this. So if you're thinking about, oh man, it's going to be really complicated, it might be. Your problem might be really complicated too. But again, you iterate over it. You figure out what you want to pull in, what kind of information you want to pull in, how I want to do my queries, how I want to do my analysis. And now it starts becoming real. It starts becoming more exciting, and I can do things that I wasn't able to do before by just simply adding in these relationships and entities. So this is where we got into a little bit of fun. We kind of had an idea. There were some people that had done some things in the past, and we're like, I see some names on here where I kind of know. You know, they've done things nefariously before. We'll go ahead and explore them. So we did, and what we actually found was this. Things that you couldn't necessarily find in a relational model or just by looking. We found that an aide to a president was funneling money. We found that some of the first families, cousins of the first families, childhood friends of Putin, like they did some really gnarly stuff in order to try and hide this information from us, kind of like there was going to be some sort of recourse if you're funneling millions of dollars of ill-gotten funds. So they did some really creative stuff, but we were able to find them eventually, right? So I think one of the coolest ones that I saw was the Putin one. I think I have the slide on here. Yes, I do. Okay, awesome. Okay, yeah. So this is also a really, really interesting one too. So Wilbur Ross, nasty guy. And I'm not going to say anything more about that because you can go and read about it. There's lots of fun little facts in that. On the website itself, on the Panama Papers, or the Panama Papers website itself, it has like a 3-page just ripping apart actions and like, you know, how far back it goes, like setting up a fund in 1970 that actually fed to a housing company, and then that did this, and it's just like, whoa, he's been planning this stuff for a long time. That's pretty crazy. I wonder how much he got away with, right? So, yeah, I recommend checking that out. But yeah, he's no longer the commerce chief. Let's say that. Here's what it looked like when we started breaking it out. A lot of little words on there, but basically tying Wilbur Ross back to people that were around Putin, holding companies that were also co-held by Putin's family members. That's not shady at all, right? No. Okay, so what we found out was Wilbur Ross, while seemingly completely out of it, he stepped down from all these positions, right? Seemingly, but in reality, very highly connected node to some very, very interesting people. So then he quit, kind of. So yeah, this is what it looked like. Here's the actual cipher code at the top, up here. How crazy easy is that? We can all read it, right? Match officer with the entity, intermediary of, contains Ross. Go to officers, return all. Boom. And we see these really dense networks here, but mainly this guy is connected to some of these very highly connected purple nodes, which are dealing money. Kind of cool. So yeah. One of my favorite things about Neo4j, besides that really cool quote we had, was the amount of information we have on our website. So this was a really cool presentation, I know, and you guys enjoyed all of it, which is clearly the case. If you want to actually download the data and spin up an EC2 instance and play with it with the actual code, you can do that. It costs no money. You go over there, you download it, spins up an EC2 instance, and now I can actually see the connections. I can see what's going on. How cool is that? That's insane. And it's not just that one not just that one experience. You can actually have fraud rings. You can go into Trump world, which is like every tweet that Trump ever had. Very fun. I don't know about you guys, but it's actually quite entertaining if you have a couple hours on your hands. But yeah, any use case you can think of. If I think basically, I'm really interested in bill of materials, or when I was talking about the infrastructure for what Microsoft was doing, it's very interesting, right? So I want to play with that a little bit more. Maybe it applies to my problem. Maybe I can solve something I couldn't solve before. So we have all of that, and it's super, super duper free. I say super duper free because it's basically just an email address, which is really cool. So there's no anyway. And you can spin up as many as you want. So it spins up, you play with it, it shuts down, you spin up another one. It's fantastic. There's also the documentation on Neo4j and Neo4j.com is constantly updated, heavily maintained, and has been 100% accurate for me so far. And I can't even believe my lips when I say that, because I've gone through so much false documentation and old documentation in my life to know that means so much for anybody who's trying to learn new technology. So this is what it looks like. Just when you spin it up, the browser, right? So you can see this is actually what you get. And when you walk through, it's going to show you a little bit of a synopsis and summary and everything like that. This is what the desktop looks like. I don't know how many people have used Neo4j, so if I'm saying stuff that you guys already know, you can just close your eyes for a few seconds. But anyway, so this is very, very straightforward. Now here's the pitch, right? I'm doing a San Diego 8-hour course. So if you can maintain this energy level for 8 hours, let's go. Let's do some cool stuff. All right, and we'll do like get down into cipher code. We'll import some CSVs. We'll start playing with nodes and all these pretty pictures, and I'll tell you about some really cool stories when I was in the government and stuff like that. You guys would love it. It's crazy, but I'm being recorded now, so I'm not going to do it. Anybody's listening? And then the graph tour, obviously we have that, which we plugged earlier. Another amazing person who I get the opportunity to work with, Max DeMarzi, is one of the smartest dudes I've met ever. Very passionate, and I can say that. He is way more passionate than I am about this, which is exciting. If somebody that smart can be that passionate, I mean, you must be very, very cool. So what he does is, in order to get all of this intelligence out and all this emotion about how awesome everything is he writes these blog posts, very in-depth blog posts about these very hard problems that he gets onto. He's kind of our rolling savant. He goes from project to project whenever something's really hard and people need help. And instead of losing that information into the ether of his brain, he gets on a plane, and in his brain, he gets on a plane and just cranks it out with like very, very specific example, like not too specific, right? But a specific example, here's where we hit troubles, here are pitfalls, here where we solve them, and in the future, we're looking to do X, Y, and Z to our database to make it better. So this is Neo4j at its heart. You have questions, we have answers. So I hope everybody learned a little bit today, and I think David wants to give you guys some free stuff for listening to me for 45 minutes. Are there any questions that I can ask or answer? I mean, I can ask you questions, but it'd be great if you guys did. What do you think? No? Nope. I was, though. So I worked, my first gig was at S3, which is the Advanced Analytics Group, and then I switched over to the NTOC, which is the Cyber Threat Group. So I don't know if you can imagine it, but like everybody in the world doesn't like the US very much, so they're trying to attack us with cyber, and usually like DDoS. So we have all these kind of firewalls around each government agency that's collecting information. So we get to do analysis on that. And again, perfect graph problem. They didn't let me use the graph database, so I used, you guessed it, Hadoop and HBase. And it took me forever. Good question. I like it. Anybody else? Yes. I don't know that one. Mark, do you know? Bipartite? It's okay. He's my my guru right now. I'm learning from him. So like you're talking about two disparate graphs and doing like analysis on two different graphs? Okay. Interesting. Okay. Stay after. We'll talk about that. I think you can solve it a different way. Cool. I think it's under 5, right? It was like, what, 3? Something crazy. Yeah, the Stanford. I was just telling Mark, you got here a little late, but I was telling him about, I was playing with the Stanford NLP thing. It's just so amazing and verbose, and there's so many things you can do with it. Yeah. So again, it's crazy. Go for it. Sure. Yep. Yep. Yeah. Exactly right. Yeah. Sure, absolutely. So I have one actor that potentially has a lot of open accounts, and all those accounts have different credit cards, and all of those credit cards have 3 different people associated with the credit card, and all of them have similar social security numbers. When we start talking about those 3, 4, 5 hop relationships, that's when we start seeing the benefit of Neo. Fundamentally, just taking it as a graph algorithm and saying, this person has a high number of centrality. Potentially, like, he knows a lot of people who are committing fraud that we caught before, right? If somehow he's been on the same check or bill or paid a credit card and split it like that, where we're seeing these connections, and it becomes more clear when we visualize it, but also when you know what you're coming in with. There's specific types of fraud that people know, things like sleeper fraud, where I have maybe 10, 15 accounts and credit cards associated with me, and building them up and tearing them down. Showing that I have a lot of monthly income slowly increasing and decreasing. So I'm trying to mimic an active user to get a credit card loan or to get a loan for a house or something like that. And when I was at Royal, when I was helping Royal Bank of Scotland, we had a lot of people that were doing that and would get these 300,000 pound British sterling pound loan and then just vanish. So they built up this fake profile, and they did it over the course of 2 or 3 years. And then as soon as they got that bank loan, they were like, later, and just bailed. And we found it. So what we did was we built, and again, this is in SAS, so we used that model in order to go back and see how many times it happened. It happened $35 million worth in 1 year that we didn't catch. So, yeah, I know, it's crazy. And that was just like the smaller threshold, right? This is people that were doing a specific type of fraud, a sleeper fraud specifically. And there's so many other ones, so many really cool ones. So I will talk about that in the training. I get a little bit excited about fraud because they're so smart. Like what they're doing is they're hyper changing. Whenever you catch one person, they switch their scheme to something else like midstream. We had this issue where suspicious activity reports were being generated at $10,000. Any transaction above $10,000 would be flagged, and would just human eyes would look at it. Does this look normal? Okay. So what we found was everybody was doing $9,900 transactions. It was like right under the threshold. We just popped it from 10,000 to 9,000, and it just like just blew out of the chart. There's like 4 and over 10,000, and then like 5,500 underneath that. So yeah, just stuff like that where they found out that threshold and they just nope, not gonna go underneath it. But again, there's so many transactions and there's so many people. They have to have some sort of threshold, right? Because a human cannot physically look at all of these transactions and say, oh, does this look normal or is this abnormal? So yeah, go ahead. Yeah, right. Yeah, sure. Network theory. I imagine so. Mine's graph theory. So my undergrad and some grad school. Yeah. Yeah. Yes. Exactly right. Yes. Yeah. 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 Sure. Huh? Sure. Sure. Oh yeah. No. Definitely not a plot. Yeah. Sure. Hmm? Yeah. Yeah. And Euler was a mathematician in the 1700s. So yeah. Sure. Very cool. Doesn't that work? Yeah. Oh, yeah. That's very cool. It's everywhere. Sure. Oh, okay. Sure. Sure. Yeah. Sure. Right. Sure. Sure. Yeah. Yeah. Sure. Mm. Mm. Mm-hmm. Mm-hmm. Sure. Absolutely. They do. I can actually take a swing at that. If you ever talk to very high up people at any of the very, very small elite intelligence agencies, they're smarter than you. It doesn't matter what your expertise is about anything, they are smarter than you. So exactly. So basically, if it's not their idea or they're not working on the project, then it's obviously not worth their time. So a lot of the people that I've come across, and that was obviously a little sarcastic, but a lot of people, it was a barrier for entry was their own pride. Maybe it was their software. Maybe they were looking to do something with the software exploit, couldn't do it fast enough. There's a lot of moving cogs in these agencies, and sometimes they just didn't catch it. They employed a lot of really smart people, but sometimes they just didn't catch it. So it's, I guess it's kind of a fake answer for your question. Does that work? We can talk about it more. Yeah, no problem. Yes. The power. Electric. I'm just kidding. I'm actually not sure what the size. Did you know what the server size was for the Panama Papers? It was small, right? It was. Yeah. So you start. So again, in the presentation, it starts off with like what 1.7 terabytes. There's a lot of white space in that. You shrink it down to what is important to us and what's not important to us, and you can shrink the data size down. Loading it is faster than reading it. I know. It's so cool, isn't it? It's really cool. I recommend it. Yeah, GraphGIS. So Graph, that's a great plug. My sales guy doing the sales guy stuff. So if you want to look into more specific use cases, we have people that have said, hey, I came across this really hard problem, and I'm willing to throw it out there for you guys. I will give you my problem statement, my data model, all my pitfalls, and some code usually as well. And it's just absolutely a great place to start if you want to start thinking about a problem differently. So it's called GraphGIS, G-I-S-T-S. On the Neo4j. Yeah, go ahead. Sure. It's fun, isn't it? Very, yeah. Cool.
We'll do one more question if anyone has, or we can wrap up.
Yeah, me. No, but I'm serious. You can shoot me an email. I can help you with it. I don't mind. Or Bloom, sorry, yes. So you mean like an actual tool, software tool? Yeah. So we have a it's paper. The data visualization. So it's called Bloom, Neo4j Bloom, and it's an add-on, and it helps you say like if I just want to do say I have movies or something, and I want to say Tom Hanks movies, it'll give me all of the movies Tom Hanks has. That nothing about the structure of the data. Oh, okay. So if you want to look at the data, if you load into Neo4j, then you can do a match in, return n, and it'll give you your entire graph. So it'll give you everything, and then from there you can build a query on top of that. I mean, as far as like just a free way to look at a query. I would have to think a little bit more about that. Sure. Absolutely. Mhm. Sure. No, I don't think we have that. Sorry. That'd be cool, though. I'm going to talk to Max about it. Yeah. No, I hear you. Yeah, that's cool. All right. No. Yeah. Oh, that must have been fun. Oh, FDA is brutal. Yeah, no, that takes forever too, right? Oh man. Okay. Well, good luck with that. All right. Well, thank you very much, everybody. That was a lot of fun.
Thanks, Justin. So David is going to do a raffle. He's going to give away some stuff. He's promised me all the Amazon gift cards.
Okay. I'm going to need your help, Subhash. Yeah, so we have a nice little Neo4j toque here, as we say in Canada. I guess beanie is the right U.S. word. So it's where everyone's name who signed in. Now, if you didn't sign in, you still want a chance to win a raffle prize. Put your business card in here right now. Anyone want to get in? All right. Let's start. You start calling I'll pick them out and you start saying the names. How about that?
Is there a Anusha Avyok? Oh, okay. Forward. Sorry. Nobody wants a t-shirt. Okay. Okay. Sorry if I screw this up. Maciel Kozirod. Is that right? I mean, I don't know. Cool. Oh, that's good. Next. This may be a little bit easier. Haichun Chen. Oh, there you go. Neeraj Gupta. I can't read this at all. I don't know if you can. Eric? Sorry about that. Mustafa Majidpur. Irene Toch. Sorry. No, that's you, right? I'm not pronouncing it. Raj Bhaskar. Sam Kaldavi. Oh, Mark Queensland. David Benjamin. RC Golak. Is that pronounced RC? ARSI? Oh. Michael Ho. Moses. Vijay C. Is there a Vijay? He's not here. He's not here. Jerry came. Jerry? I wanted the good stuff.
Oh, wait, this is a good one. This is a good one.
All right. Okay, thank you everyone for coming. If you want to stick around and do a walkthrough of Whitespace, please feel free, but otherwise, if not, I'll see you the next meetup. By the way, next meetup is going to be May 9th. It's going to be on Cassandra and Kafka. It's going to be at the Verizon headquarters down the street in Playa Vista. Thanks again. Victor, you want to say something? Are you good? Cool. Feel free to hang out if you want to go on the tour.